Okay, 3.3 characteristics of polynomial functions and factor form. Okay, definition. Family of polynomial functions is a set of polynomial functions whose equations have the same degree and whose graph have common characteristics. So the best thing we could do, the easiest thing to remember this is common characteristics would be, say, same x-intercepts. Okay, so we could have a parabola quadratic that goes this way, and then have a quadratic that faces downwards. Okay, so this would belong to the same family because they say they have the same x-intercepts, and also they would have the same degree because they're both x squared. I apologize for my voice, I'm losing it a bit, so I'll do my best. Okay, order, so we have to know this. Order, the exponent to which each factor in algebraic expression is raised. Okay, so for instance, let's just say we had an equation as such. Excuse me. So we have the order is the numbers or the exponents at the top here. Okay, the exponent to which each factor is raised to. Okay, so this one here is an order of 2. On top of this bracket, it would be 1, so the order of 1. And this one here, 3 is the order of 3. So order 3. Okay, and then what happens at each order, something happens. When we have an odd order, we're going to cross through the x-intercept. So if it's odd, we're going to go through the x-intercepts. Okay, if it is even, we are going to touch the x-intercept. So odd, we're going to cut through it, and then even, we're going to touch it. And I'll show you with some examples. Okay, scratch the graph of each function. Okay, so you would have learned through the previous chapter in 3.23 section about end behaviors. Okay, so this one here is an odd function. Odd functions will go in opposite directions. So like a linear function could go this way, or it could go this way. Okay, so they have opposite endpoints, end behaviors. So one's going negative infinity, and one's going positive infinity, and likewise. Whereas an even function, they either both go positive or they both go negative for the end behaviors for y. Okay, so right here we have a order of 1, order of 1, order of 1. So 1, 2, and 3 gives us the third degree, which is a cubic function. So this is a cubic function and it's a positive value. So if it's a positive cubic function, we're gonna have end behaviors in these directions through quadrants 1 and 3. Okay, so these are your x-intercepts here. So we have an x-intercept at negative 3. We have an x-intercept at positive 2. And then we have an x-intercept and -1. Okay, so we know the graph is going to go through these points here. If I say sketch, I want it to be rough, I guess. If I say detailed, I want a few more pieces of information. So I want the x-intercepts, so I'm going to put a detailed sketch. So I want the x-intercepts. I want the y-intercept. And points in between. Okay, but what I mean by points in between is I want to know where these values are here. Okay, because we're going to have some hills and valleys, some local max or minimum values. So I want to find out where those are. Okay, so we're gonna plug these values into the equation and see what we get as our answer. So we're gonna plug in -2 first. So -2 plus 3, -2 minus 2, and -2 plus 1. So that gives us 1 times -4 times -1, which gives us +4. So our point is -2 and 4. Okay, we're going to do the same for 0 and 1. 0, you could do it in your head. So you have 3 times negative, 0 doesn't make any difference. So 3 times -2 is -6, times +1 is still -6. So 0, -6. Which also is our y-intercept. Okay, our y-intercept where x is 0. Now I'm going to try another value of 1. I plug 1 in here, and 4 times -1 is -4, times 2 is -8. So -1 and, sorry, +1 and -8. Okay, and now I'm going to now connect all the dots. So we're going to go, I don't care about the ends that far, as long as the arrows go through after. So remember with an odd degrees, we're going to cut through the x-intercept. So odd order, sorry, we're going to cut through. So we cut through, we're going to go up to this point, cut through again, because these are orders of 1. They're all 1, so we're going to cut through the x-intercept, through this point, and then back up through this one, and then it continues both ways. Okay, so that would be your graph for the first one. Next one. Okay, this one doesn't give us tons of information. So it says our zeros are 5 and -4. But we have an order 2 and another order of 2. Okay, so what happens at 2, if it's an order 2, it touches the x-intercepts. Okay, touches doesn't cross through. If I have order 2, that gives us a degree of 4. If we have a degree of 4, we have a quartic function. And it doesn't say anything about the a value, so we don't have an equation, so we'd assume that it's positive. So if it's an even polynomial function, it's going to go through quadrants 1 and 2. Okay, so it's going to end behaviors in that way, and we're going to touch through these x-intercepts. We can't find the y-intercept because we don't have an equation, and we can't do any other points any points in between. So what we're doing is just going to connect these dots, going with what we know about orders 2. So we're going to come down here, we're going to touch the x-axis, the x-intercept, and then change direction. Okay, but we know we have to touch this one as well. So we're going to come back, touch this one, and then exit. Okay, so that you can go as high or low as you want here. You have no idea because there's no equation. So it should look like a double.